We left off with these engines freshly seal coated and reassembled after two beautiful cylinder heads were prepared for this main event. And while you weren't looking, I completely recleaned every sealing surface, every lifter, rocker, fastener, and at the very least, I'm really well prepared. The cylinder heads sure went through a lot in the last video, and somewhere along the way, despite all my carefulness, I did manage to leave a mark in the quench area on the new one. It's okay, it doesn't line up with the head gasket fire ring, but even when you're really careful, stuff like this can happen. I got really lucky this time. I'll spare you from all the process of polishing anything and everything going forward, but I'll tell you how I did it just so you'll understand the results that you're looking at. But I'm done filming it and I'm done editing it. There isn't so much as a fingerprint left on these anymore, and that's a good thing because I really want to get right to it. I got everything laid out, and before this video ends, the GSX is going to have an engine again. I've still only got one set of cam gears, the others haven't arrived yet, but that doesn't have to stop me from installing and assembling both of these heads. If the gears show up, we'll just have two engines. But here we go, starting with the 7 bolts MLS gasket. I'm 20 thousandths or 0.5 mil overbore on my pistons, and that's about as big as you ever want to go on this gasket. This gasket didn't go to waste when it didn't fit the 6 bolt. I had the perfect candidate for it right outside the flap at the time. Both of these blocks have Manley Turbo Tough I-beams, but this is the one that's got JE 9:1 compression pistons in it. But because its head studs are 1 millimeter smaller than the default 6 bolts 12 millimeter stud holes, I opted for a materials upgrade and went with a brand new set of ARP L19s. Aside from the special handling and packaging requirements, because these things can oxidize and corrode and react with the atmosphere, other than that, the process is mostly the same as the normal ARP studs, only the torque specifications change. Just like the normal ARP studs, washers go on first, both sides lubed, and first because you can't fit them on after the stud's installed. You want to make sure that the top threads are all ARP lubed and the block side of the threads go in dry. Finger tight only, not hand tight, nothing more than finger tight. Go ahead and make sure you're at the bottom of the hole, sure, but back it off and finger tight. Pro tip, put the nuts flush on the top of the studs before you install them with your Allen wrench. Act like it's your valve cover bolts, 1 to 2 foot-pounds kind of thing, you know, so you're talking inch-pounds here really. Always follow the instructions for the fasteners which are included with your studs, which in my case, there aren't any, and I can't find them on their website either, so based on consensus of others with the same questions that were already answered on the interwebs, I followed the 625 plus instructions, torque sequence, and torque specifications, which I did find easily on ARP's website. I did 33, 66, and 101 foot-pounds. Always torque 4G head studs a second time at torque spec and sequence. It's not the studs that stretch, it's the gasket and the cylinder head that compress once it's fully under load. And that can decrease load on the one where you started versus the one where you ended when you're in your sequence. So sometimes nothing settles and that's great, but do it twice anyway just to know that for sure. It's peace of mind the first time you start it up. Moving on to that 6-bolt twin, and of course I mean in appearance only. You might remember that this block is bored 40 over. A full millimeter bigger of a hole, indeed. I told you about this SCE head gasket for the 4G63 in the last video, and they started around 250 bucks. It includes a Vulcan ring assembly that presses into the head and seals against the block with no machining required. This pit's bore's even bigger than mine, and rumor has it that they're even reusable. If you had a problem at the track and you had to pull it and reinstall it, it's going to seal and get you through it if you can clean it all up and get the rings back in their grooves. It's pretty awesome, but there's something you need to know about it. The grooves that I'm talking about are only on one side of the Vulcan rings, and that's intentional. The block's flat cast iron, the head's aluminum. This works because the head holds these centered. The flat part seals against the cast iron, you see that? So put these on the block, groove side up against the head. It's a dynamite product. Just be aware that after you get your head gasket on there facing the right way with all the holes aligned, that you still have at least 4 extra chances to fail while installing it. Brand new set of 6-bolt 12mm standard ARPs, because these have a proven record that I know people are going to agree with in the comments. Probably more than any other thing, the standard head stud size is the only advantage that a 6-bolt 4G63 has over the design of the 7-bolt. Moving beyond the stock factory materials from 3 decades past, now there are options, and honestly there's a lot more options for the 7-bolt than there are for the 6. You can get L19s for about $400 for either one, but there's no 625 custom-made 12mm stud available. Not at all for your 6-bolt. So even if the stud size of a 6-bolt was an advantage, then there's modern materials that can still bridge or exceed that divide for the 7-bolt. 625s match or exceed the L19's tensile strength, but they don't degrade or require special handling. Or you can just install half-inch studs and use the cheap ones. However you go, these 12mm ARP head studs and this SCE head gasket are enough for everything that this street car is ever going to see. I gave these 30, 60, 92 foot-pounds. I gave them a little bit extra, but it's less than 2%, once again circling back a second time at the end. It feels great to have those blocks sealed up, but there's still hundreds upon hundreds of parts involved with assembling 2 cylinder heads, as well as the rest of the timing stuff that makes them all work to deal with. I hinted that changes were coming to this one, and I wasn't just talking about the shine seal treatment on all the billet parts. I'm glad I did that, but that was just the beginning of the beginning. This is now the middle of the beginning, where we get to do all the special and extra things, transform it into a completely different form than its original being. That's right. All this time the King of Bling was just in its pupa stage. The metamorphosis begins. Most of it's right here in that big white box, but there's more. There's much more. Stuff to save my AC system, dress up parts for both engines, more of that on the way. All the internals for the Gliptol head are all brand new, all of it. I've got new top line lifters, a brand new set of Evo rockers, and when you add up the cost of 16 of these things, these Evo rockers alone are about 1/5 of the cost of the build of that whole cylinder head. A set of these cost almost as much as camshafts now. One product that I'm really lucky to have, considering my time and financial investment in these engines, are these Denstoj rocker retainers. We're going to go all the way through this topic of installation with the cylinder head assembly, but there's still a lot of stuff that I've got to do to the timing side before that begins, and one of them being these cam gears that I've developed a love-hate relationship with. I absolutely love everything about these cam gears, and I just hate it that the other ones I ordered are still not here after several months. They're very particular to my build because of the cam angle sensor that I'm adamant about using to a nearly useless degree to most of you DSMers that don't have this already. Yeah, I know there's plenty of other cam angle sensor options that I could use, but this one is mine. I like this design because it's not mechanical. Its moving parts have no moving parts. No shafts, bearings, seals, paint, fancy billet covers, or anything like that. These two pieces are just passengers on the cam gears kind of thing. This takes up the least space because it's completely hidden under other components on the opposite side of the engine bay and under a timing cover. This is both easier to wire for me and invisible. This cam angle sensor was only available on vehicles sold in '95 and for most of the 1996 production year. And I believe this was by far the best one, and I am biased, but it does carry the weight of having to use a cam gear that's still designed to work with this ring. And not all of them are. These beautiful Fidenza gears are the ones that have it though. They're the ones that fit my build. For the GSX, everything going in that head is used. It's all brand new stuff that was good back on the old engine. The old block didn't suffer a cylinder head related failure, so it's all in great shape. I put a great set of rockers together. These were put away oily, cleaned up perfectly, rust free. Good rollers, pads, and buckets. I found 4 with slight imperfections, and I found 4 better, flawless ones in my sack of spares. So anyway, I cleaned up all my 3rd revision lifters. I got a video about that already. New seals, and I mean in more than one way. One of these I even have to polish, but one of these seals is unique to the 1995 cylinder head because it has no cam angle sensor hanging off that other sides. ARP bolts for both engines, and someone asked me how I'm keeping my AC with the Frontline Fab oil pumps. Easy. I'm getting fittings that let me tuck all that plumbing behind the belt drive. That's what these are all about, and we'll do that in just a minute. Got another Kiggly oil pressure Oh, I shouldn't open that box. That just cost me money. I thought I had one all along, and I find out on camera that I don't. Gotta buy another one of those. Let's open a different Kiggly box, shall we? This is a great one. This right here is a 12-tooth crank trigger wheel. And this is one bad mamma jamma right here. Instead of using a stamped sheet metal trigger wheel, this is a burly milled 12-1 tooth trigger wheel for advanced engine management systems. This won't work with a factory ECU. It uses the Evo cam sensor, and it provides much greater sensing resolution and angle syncing to the ECU for data accuracy. The problem with stamped trigger wheels is that they can strip and slip in really high horsepower builds. But this one can't because it's a 1/2 inch thick and it rides on the keyway, occupying all of that space that used to be filled by the balancer gear. And now there's no need for high friction shim rings to ensure that it stays put. The sensor's sold separately, but everyone who sells this part has it. It comes with everything else necessary to plug and play on your 2G. Some low-level wiring is going to be required to add this crank trigger to a 1G. Plus, it's a beautiful thing just hanging out with all the rest. Look at that. Okay, it's fine. It's unpolished. Let's try that all over again. Now it's hand polished with Blue Magic, washed and shine sealed. The bolt that was included for the crank trigger sensor bracket was a couple of threads too long for this front case, so I switched it out for a slightly shorter cap screw and kept the washer in there. Ooh, shiny. Speaking of which, everybody knows what this is by now. Aside from it being a raw, unpolished, and well-handled billet part, it centers and supports a mechanical fuel pump that will be driven off the exhaust cam using a Lovejoy coupler. This removes the necessity of running multiple fuel pumps for making big power, or from running big heavy-gauge circuits all the way back to the fuel tank. Basically, as long as the engine is spinning with this fuel pump, it has the fuel it needs. But this is just the bracket that holds it, and the dang cam angle sensor goes on it first. Just 2 bolts hold that on, and all of the 2G DSM heads have these holes drilled and tapped for the sensor, even if they didn't come with it. And most of them didn't. That out of the way, let's go ahead and put this fuel pump bracket. Aww. I asked if this fit. They said yes, this looks like a nope. But it was probably really a yes asterisk. I never heard the asterisk part. You gotta be smarter than me to hear all the asterisks. The sensor's a necessity for me, and you can see that I've already started planning this thing's demise. That's the most pronounced part of the sensor right there that I need to cut out for, and let's go right to work with the carbides, grinding on my brand new billet parts. This is normal, right? People do this, don't they? I think this is okay. It fits well enough for me to figure out that I still need to remove a ton of other material, drill relief holes for the bolts, and somehow transfer those bolt hole locations over to this thing. I'm going to use a paint marker. I wound up using a whole lot more paint than that, but once achieved, I taped it up to keep from scratching it. Used a couple of drill bits to sneak up on the true centers from my paint marks to cut relief holes for the bolts, and removed really the largest bulk of material the fastest right here with these. Next, I grabbed a 3/8 inch end mill bit and patiently shaved all of that in, running back and forth from the clean room for a fit for a couple of hours, shaved down layer upon layer of aluminum in the shape of that sensor, the bolts, the washers, and the reliefs for all of its protrusions. The nice CNC was in the previous video. Go watch that one if you need that right now. I raised the drill press table slowly, a tiny fraction of an inch at a time, just to go easy on the equipment. I did all this by hand. This is not my drill press, not my bearings. And this is ultimately what I came up with.
And suddenly it's completely polished.
Yeah, and you know it's polished too.
There you go. There's my drill press CNC work.
Sorry, Marco, not my prettiest work, but it's really not that bad. You're going to slip here and there doing things like this by hand. Nobody's going to be able to see this, but it works.
Completely polished.
That was black rouge, white rouge on the big wheel, Blue Magic, washed, and then shine sealed. Now, if this were the original cylinder head, I'd have to make sure that all my timing side oil galley plugs were all in place. 1/8 inch BSPT plugs. You can see the original G6K head has 3 of the 4 oil galley plugs missing from those, but the G6S doesn't have them, so I can go right to work installing this thing. I definitely compromised its strength by cutting through it all pretty like, but it's fastened by tapered machine screws on both ends, centering the rest of both assemblies, and would have still worked if I had chopped a whole section completely out of it. It looks good enough, and once the cam gear and the reluctor wheel are in there, it'll be mostly impossible to see it. This allowed all of these parts to share the same space for a stealth install, and it serves my purposes. Next, I'm going over all my previous work on the front case, the water pump, timing mount, because all of this except the oil pump is just finger tight right now, or not at spec anyway. I'm done making changes to most all of this, so I'm torquing, then marking every bolt with a paint marker to remind me what is and isn't done at a glance. Using this opportunity to also grease the tensioner arm. I covered all of this 2 videos ago with torque specs and part numbers, so I'm just breezing right through this and we're done. Here comes the factory intake cam gear now that we've got the bottom half of the timing side straight. To finish up the top half, I have to harvest this reluctor wheel and transfer it over to the other gear. And suddenly both of the Fidanza cam gears are polished. I used rotary tools with teeny tiny flannel wheels and blue magic metal polish before washing and then shine sealing these. I don't want to use the hammer with the impact driver to take this thing off. I just like the fit of this impact driver, but I still keep the hammer close by just to make the part nervous enough so that it lets go of these screws that I don't want to replace. And it worked. I love that trick. You don't have to mark anything because it's keyed to only go on one way. A quick cleanup later, and let's lop the big leg of the reluctor wheel off first with a cutoff wheel. Because with my crank sensor that only has its church teeth, this is necessary. Due to the missing tooth, if you start it and it's on the missing tooth spot, it can cause sync problems that even some advanced engine management systems still struggle to overcome. Cutting off the big lump gives it a top dead center signal it needs to correct for this. The cams turn at half the speed of the crank, so every 2 complete engine revolutions is 1 full engine cycle back to top dead center at the camshafts. It doesn't need the bottom lump. That one can actually confuse it. It just needs to know when number 1 is at TDC, not both number 1 and 4. This was probably poorly described, but trust me, everything I got wrong will be in the comments. I'm just meeting future requirements by doing this right now. It looks like I fiddled with this a whole lot, however that was by far the easiest cam angle sensor mod I've ever had to do. The sensor for this wheel is still available brand new for the Dodge Avenger, but good luck finding that reluctor wheel for it if your car didn't come with it with this gear on it. This is the one cam angle sensor that's not in Kiggly's instructions, and I sure hope this works. All I have to do now is screw the thing down the same way, and it's a snug, perfect fit, because it's as if these awesome and hard to get cam gears were designed specifically for my particular build. Not everyone's into the bling thing because it's hard to do it right, and a surprisingly large group of people don't like hard work these days, but there you go. Both of the cam gears are now prepped and ready to go. I still need to do all those oil galley plugs though. I'm slacking, I know. Permatex former gasket. I'm ripping the head off of a Q-tip, all of it, until nary a strand of cotton fiber remains, just the paper. I apply the sealant to the threads of both clean parts, let it tack, and then install the plugs. The G6S head has 5 plugs. The G6K has 9. I'm one of those dudes with an 1/8 inch BSP T-tap for moments just like this. If you own a Mitsubishi, you need one of these. Anyway, I ripped through all those plug installs, sealed them all up, and they ain't going nowhere. And I put the cam angle sensor on the 6-bolt head too, just to clear off the workbench. This keeps getting better and better as I clear off that workbench. Of course, I don't have another one of those fancy fuel pump drive systems for a spare engine, so the stock powder-coated timing tins are just going to have to do here. I know, it's a pretty big contrast. I had to deal. Now to hopefully fix the AC issue that I'm told I'm supposed to have with this oil pump. I'm not sure there was actually ever really a problem with this, but once I set eyes on it, I felt like these Radium 10 ORB banjo fittings would remedy the fit just fine. So first we do the FA part. There's a snap ring on top, take that off, press the 10AN banjo fitting off the ORB base. You see it's got 2 different O-rings so it swivels wherever you need it, and it's a great flowing low profile fitting. It's O-ringed on the bottom too. I use its Allen socket to install the ORB side, and then all you have to do is press the banjo back on, install the snap ring, and you're done. Now, do that again for the other one, and what you end up with on the other side is just about as stealth of a reroute as you can possibly get. The timing belt's pretty thick, the AC belt operates outside of that range, and because these fittings are shorter than the timing belt's width, I'll be able to attach 10AN hoses below the timing belt and completely dodge all of that AC belt drive nonsense. Looking at the front of it, the AC compressor's well above all this, so I guess we'll see. I'm keeping my AC system. As if we aren't already having enough fun, let's go ahead and put all the stuff inside the thing. Look at that. This thing's so clean you can actually see ghost-like reflections of the spark plugs in the plug wells. Those are just in there for now just to keep the debris out. And I'm glad I'm not editing a lifter cleaning video again. I found it cool that they arranged themselves into this shape inside this container. They're clean and oiled, the rockers are freshly cleaned, and I'll take care of the oil part in a bit. But now for something I've been dying to check out. This is something that I've never even had before. Like the slogan says, rev with peace of mind, these are cheap insurance against the damages that can occur from kicking a rocker under load or at speed. 4G63s are one of the special ones that actually allow you to replace rocker arms without removing the camshafts. I'm not kidding. But it's only possible because of how the HLAs work when there's no oil pressure and the engine's off. The purpose of these retainers is to physically attach the rocker to the HLA as an assembly. And there's 2 packages here because one's for the cast rockers and the other is for the stamped units. Packaging says pressed, so yeah, we'll go with that. DSMs came with cast rockers. The ones I'm using are small hole versions, and what the small hole is referring to are the ID of the inner bearing race hole. I have a big hole lifter over here for reference. You can see how the bearing hole is bigger, but otherwise they're the exact same shape and physical dimensions. Nothing else of significance changes about them. Same can be said about the physical dimensions of the top line rockers that have no hole whatsoever in their bearing. I compared those already and they're identical too. So the cast rocker retainers are going to fit any cast rocker you have. I've also got the stamped rocker arms here, or pressed. These are the Evo rocker arms. There's a rumor floating around that these can get bent, and I haven't seen that happen, but it does make sense. The same conditions that can break a cast rocker could bend a stamped one. It's a different material, so it's completely fair and logical. Evos are renowned for making tons of power, and it's not because of their rocker materials, but these are a different shape, so naturally there's a different set of retainers for these. But when you install these clips, you anchor them to your lifters or your hydraulic lash adjusters so that they absolutely can't go anywhere. It's pretty obvious based off of their shape how these fit the rocker. There's 3 fingers and you're not going to get it to just press easily on and off. That's not the point of these. Start with the 2 prongs over by the roller and then tug that other last one on the other side just clear of the edge. And they press right on with your fingertips. I'm surprised by the rigidity and strength of this material for being as light as it is, but we've come nowhere close to doing this job correctly. That's just how the retainer holds onto the rocker and how that fits that thing, you know? See, here's the HLA that it's supposed to anchor itself to, and you can't get it in there with the retainers installed. So to install these, you place the ball head of your lifter against the curved face of the clip, and you mash the living daylights out of it to get it in there. Once you've done that, it's essential that you test the fit of it where it surrounds the narrow part of that lifter. And we're not going to focus on that too much at the moment. With this clip first installed on the lifter, now you just do that 3-finger trick thing. Start with the 2 on the roller side and tug on the other one, and the retainer clip firmly secures the 2 parts together. You just need to make sure that you've got it all the way down on there, and after that it's not going to let go easily. There's normally nothing holding these 2 parts together like this, but that test fit and feel thing that I was talking about, before you attach the clips to the rockers, you got to make sure the fit with your lifter is right by shaking it. If when you shake your lifter and retainer clip, it doesn't spin, wiggle, and rotate freely, then you need to spread it. I was able to massage this one into shape off camera and get it sorted without taking it back apart, so it's not a good example. Let's try that again. Occasionally you find a tight one and you need to loosen it up, so don't do this by grabbing each one of the tabs with pliers and prying on one side or the other. Though it might work, you're unlikely to get consistent centered results with it, and you risk damaging the retainer. I'm using flat nose pliers on purpose here because they're a perfect sort of ream-like thing to affect the full length of the tabs that engage the lift or groove. Either by jamming the clip down on it or spreading the pliers with the handle end, you can influence that gap to loosen up its grip a little bit. No need to be a brute about it. This is not a defect, and you'd want the part to be tighter rather than looser anyway, so that you can dial this in perfectly with your particular lifters. And now that I've got it snapped back over the lifter, look at that. Look at how it's behaving when you shake it. That's what you want to see right there. It holds on loosely, but don't let it go. There's very few of my set need anything at all to fit like this. Most of them fit perfectly. I think the pliers only move like 3 times here, and there's 16 of these clips, so that's pretty daggone good. Like I said, I'd rather dial it in and make sure they're all right, so check them. HLAs are like little oil pumps that actually help lubricate everything stacked on top of them. And at high RPMs, while the cam lobes are just beating on them relentless, it's possible for the lash adjusters to run out of oil if they can't replenish it faster than it's getting beaten out of them. So if you can change a lifter when there's no oil pressure, what do you think is likely to happen when you're smacking it 70 times per second? That's up in the valve float territory. Let's say that happens, and now what do you get? And if the rocker kicks, now suddenly you've lost half the airflow to only one hole, and if it doesn't, okay, fine. Add a money shift to the mix. How about now? Yeah, probably. All right, so we're beating up our valve train and giving you some proverbial examples, but kicking a rocker can destroy an expensive engine. If it's on the intake side, you could even have a fire. On the exhaust, a crash, a fire, and 20 million tons of crude where the front fell off. Your bearings won't like any of it, and don't forget you also have a hard metal thing that's getting crunched up in your valve springs. So it's an incredibly stupid problem to have, but it only exists because these rockers just sit on top of the lifter and valve with nothing other than their shape until they get sandwiched by the camshaft that smacks them around for the rest of their lives. So these clips solve a unique and always negative problem for engines that will be used beyond their originally engineered intent. And these retainers ensure that whatever conditions your oil system manages to create because of what you're doing to it, that your rocker arms aren't going anywhere. I don't think this is just a clever invention. This is sheer genius in my book. This should be essential equipment for road racing, drag racing, really anywhere people are pushing the limits of their 4G. But these would still do the exact same thing on a street build too. I just can't find a downside anywhere. Their negligible weight sits directly centered on the pivot point of the rocker arm, which really isn't supposed to move, so there's really no articulating mass. The whole set weighs practically nothing anyway, less than even a gram apiece. They fit beautifully, they feel like they've gone through some serious hardening processes, and the peace of mind for me has already set in. Denstoj is an Australian company that doesn't just make these for DSMs, they also have them for Audi E8 55, Nissan SR20, Subaru FA and FB, and the Toyota G16E GTS. If you want to learn more, there's their website right there, denstoj.com.au. Many of our favorite speed shops here in the United States carry these as well. But here we are, now with the set for the pressed Evo rockers, and these fit a little bit different. Rather than pressing these in from the bottom side of the rocker, these just slide on to the lifter side. So instead of installing these on the lifters first, you install these on the rockers, and they're flexible enough to just let you pop the lifters right into the rockers after the fact. So you can actually prep these on all of your rocker arms in advance. They're a little bit easier to install than the cast versions, but nowhere along the way have you seen me really need any tools for assembly of any of them. Maybe just for the adjustment of the cast units if you can't massage them back into shape, but they're really easy to add to your build. I had to adjust 0 of the Evo retainers to fit loosely. With the top line lifter set, the fit was perfect on all 16. I'm not sure if the detent below the ball end of the lifter is narrower on these, and I suppose that I could have measured the lifter types and found out, but I didn't. It's not actually a critical piece of information, and it's more likely that the retainers are different because their design is different and they fit different. I just wanted you to be aware that you don't want the clips squeezing the lifters once they're assembled because that would score them and cause wear on both parts. It's extremely cool that Denstoj makes a kit for all of the rocker arm designs available for the 4G63. They didn't just stop at the Evos and say, hey, we did it. When you install these correctly, the clips and the lifters don't actually come in contact with each other unless they meet the conditions where one might take off. So that means there's going to be no wear whatsoever from their inclusion. Just install them correctly so that they do their job once called upon. Extremely simple, extremely brilliant, well-engineered product. These are a thing in case you didn't know. Thank you, Dennis, for bringing these to my attention. If you're just tuning in, it's camshaft time here on Jaffermobile, where we're assembling both GSX engines. And we're going to do the 7-bolt first. We have a set of billet GSC Stage 2 camshafts here, 441 thousandths lift on the intake, 433 thousandths on the exhaust, both at 274 degrees duration at 40 thousandths lift, and 110 degree lobe separation angle when installed at the recommended center lines. I'll take it. I've driven an Evo 10 on the street with these cams and found them to be exactly the behavior modifier that I was looking for. Thank you, Matt Russell. You've done an incredible job building an exquisitely tuned Evo 10, brother. As seen on Jaffermobile, love the wheels. But the finishing job and polishing job on both of these units straight out of the box is absolutely gorgeous. Get on with the Jaffro. Quick last second cleanup of the already cleaned parts and some lube and some cam caps and snug them all down in the tightening order, of course. And now to do the exact same thing to the intake side. Quick cleanup, unbox the intake camshaft, put it down for its extreme close-up ogling. These don't even look metal to me. They've been through so much finishing work beyond the milling, grinding, and polishing. In person, they look blued. It's like there's an additional coating, and there probably is. But I didn't do that research or care about that or what they looked like when I bought them. I made my purchase based off the behavior modifier characteristics I was talking about earlier that I felt from the driver's seat. Lubed it and run those suckers down by hand, just like the other one. In the tightening order, of course. Slowly and gradually, but most importantly, just do it evenly across each cap. Try to keep those level. Then torque them all down to 14 pounds in the proper torque sequence. And I've outlined it right here. It's kind of a spiral. It's most important that the 6 caps get torqued in this order, not necessarily that the 12 bolts on each cam get torqued in that order or that you have to actually do a spiral. But if you start one from the 3rd cap from the timing side going toward the center, you end up with the correct tightening order. With heavy enough valve springs, it's actually possible to break a cast camshaft by doing this wrong enough. I wouldn't hurt a billet crank doing it wrong, but I still wouldn't want to do it wrong. So I slapped the valve cover on it to keep the dust out for now, and I'm going to lube and install these factory cam seals to get ready for what this one's going to get next. I'm using the correct Miller cam seal driver that perfectly aligns the cam seals with the journals. You just beat on it until it makes the right sound. The sound that means you're done. And now let's do the same for the 6-bolt GSX engine. I bought these camshafts a decade ago. These are Kelford TX 272s, and I almost bought the 280s, but then I reminded myself that this car lives most of its life on the street, and I calmed down. All that happened a decade ago. I'm perfectly fine today. And when we compare one cam card against the other, it's pretty easy to see that these two are fairly comparable, despite the manufacturers being different. There's only a difference of 2 degrees of duration and 12 thousandths of an inch only on the intake valves, but all of this in the GSC cam's favor, but otherwise the center lines and the lobe separation angles are still the same. If your camshafts have no markings, you'll always know on a 4G63 that you've got the intake cam because it's slotted on the end for the far more common cam angle sensor that my car does not have. Naturally, the exhaust cam will not have this slot. Between these 6 and 7 bolt twin builds, you'll see that the parts that I've used have been very similarly matched, but they're not identical. The parts I've selected accommodate the differences between the different generations and these different parts, but they're both built to the same standards otherwise. I'll probably feel the differences in the camshafts a lot less than I'll feel the difference in the port job and the valve sizes between these two cylinder heads. The cams are similar, but the tunes will have to be very different because even though they both look the same, these two heads are going to flow nothing alike. Their displacements are different, and there's a half point of compression ratio difference between these two engines. You've already watched me do all of this, and my battery died, so we're moving on. Cam seals for the 6-bolt build. Sealing it up. I still don't have any cam gears. I really don't care at this point. It's only like the 35th thing that's managed to delay this one, and we've got a different one over there that we can play with still, so let's go do that. I thought I was being clever using a stud welder and a slide hammer to pull the dowel pin out of the camshaft. And you'll notice that I'm not doing this directly against my nice camshaft. I've got a plug threaded in there to ground it against. I tried both size studs and it doesn't work. I failed so hard so many times that it turned me blurry. I found it really difficult to work like this, so that I had to change my method back to something more reliable. The old hammer and vice grips method. Unfortunately, the focus effect takes a minute to kick back in after it's administered properly. But I had to remove this pin because my fuel pump drive requires the use of a longer one that actually turns out to be too long with these cam gears, so I had to cut it right back down again. You want it to protrude enough through the cam gear that it engages with at least 95% of that groove inside the Lovejoy coupler for it. This pin's slightly larger than the groove, so it's an interference fit, and you should take every measure necessary to get the Lovejoy coupler on center, leaving just a hair's thickness of a gap before the end of that groove so that the coupler meets the gear flush and doesn't interfere with the pin when it's torqued. I used blue thread locker compound on both of the bolts, got the valve cover back out of the way again, and then grabbed each cam by the hex with a wrench to hold it still while I torqued each bolt to 70 foot-pounds. I'm not finishing the fuel pump installation in this video, but these parts need to be here first, as well as one more that just came in before I can put a timing belt on it. The Evolution cam angle sensor. This is the cam sensor that's used to interface with that 12-1 Kiggly crankshaft timing gear kit. The fit of the sensor is extremely specific. You're supposed to have a gap of 25 to 30 thousandths of an inch for this one to read correctly, and who knows where this is even starting out. I can tell by this fit and feeler gauge it's wrong, but fortunately there's shims included, and enough of them that I could ultimately meet that requirement. I wound up needing all 4, but now with that complete, let's put this thing in time because it's all here. I loosened all the spark plugs to make this easier on myself. I really don't need compression yet. Previously, I had turned the crank back 90 degrees so that the pistons would be well out of the way of the valves as I assembled the cylinder head. And now that the head's in place at top dead center, we just need to turn the crankshaft 90 degrees clockwise back to dead center again. The belt that I'm using is the Mitsubishi Kevlar belt. As you can clearly see, all of the technical instructions and documentation for this are right there on this sticker. Turns out I do actually have to remove an oil line to change the timing belt, but that's fine. Putting the timing belt on is something that I've done 100 times and oh no, I've gone blurry again. My bad. Kind of zoned out. You line up your timing belt marks, start the crank gear, and work your way up over the cam gears and do the tensioner pulley last. But in all the times that I've ever done this, I've never pointed out this one detail about the timing procedure. The 1G and the 2G tensioner assemblies are backwards from one another. I'm going to cover the instructions for the 2G 7 bolt and what's wrong with them, because there's some misleading info in there and an inherent problem engineered right into all of it. But more likely, it's a misinterpretation into English rather than any intent for Mitsubishi to mislead anyone. The engineering part is still there though. I'm going to do this by the book, but you'll see what happens if you do this job exactly as instructed. Before we even begin, I want to point out that step 10 in the service manual is completely retarded. See, here's the 6-bolt 1G tensioner. The tensioner pulley rotates clockwise to achieve belt tension, the same direction the fastener does to achieve its torque load. But on the 2G, belt tension is achieved by rotating the tensioner counterclockwise. And that's the opposite direction the fastener needs to achieve its torque load. You see where this is going already. The 2G, it's switched. It goes that way. The instructions say to lift up, but you can't because it hits the water pump. That's as high as it can go. Lift up, but there's a little arrow of rotation. And the problem with this, why I say that it's retarded, is because if you can push down that as hard as you want, and you tighten this bolt, what winds up happening is tightening the bolt turns the pulley. And once that happens, now the belt's loose and it's useless. So when you're doing this job, you can't actually even begin step 10 without using the special tools, and it doesn't mention them until a few steps later. That's my only rant, and I'll show you why that's important. I'm going to go ahead and tension this with this tool, and by doing this, I'm just going to preload it a bit. I can hold it in place, torque this bolt down, and I can keep it from moving. But you'll see that it still tries to move, and it puts a harder load on that wrench. So I just dropped it. And I'm in a position now where the belt's actually tight enough to complete the next several steps. That's the important thing. The first thing you're supposed to do is tension that enough that you can then rotate the crankshaft 90 degrees back, 90 degrees forward, realign up all of your timing marks, and then properly determine the tension that's supposed to be on that pulley. In order to do a 2G timing job with a good bit of success, it's ideal that you disregard some of the service manual instructions. And I will show you how and why. Install the special tool. You're aiming for 31.2 inch-pounds on this tool when you take this bolt loose. Alright, so she's loose. Make it 31.2. Looks like right about there. And you see that angle? You see the angle of the tool? What you really want to do is just put a little extra stank on it and try to hold it there. I'm going to get it snug first, and then we're going to torque it. And what I'm going to do is switch tools here. I'm going to use this to hold it in place while I torque this to 35 foot-pounds. Pretty much got it. Made it to 33.4. I'm happy with that for the time being. Now let's check the angles. I don't know, maybe. We'll give her a whirl. You're supposed to crank this over, 2 full revolutions of the engine, and then line all your marks back up. There we go. Check to see if that spins freely, and it does, very freely in fact. Let's talk about that. Make sure that the auto tensioner setting wire moves freely with a grain of salt, because it's somewhere between an incomplete fact and a bald-faced lie. If the pin spins freely and you can take it out and put it back in, then you failed. Too many people believe this is how this is supposed to work. Using feeler gauges, if you were to check the tensioner arm gap, once you come up with the pin moves freely position, you come up with 3.23 millimeters. And that's a whole millimeter short of where you really need to be. That's way too tight. That'll be the end of your oil pump gear. It has no room to absorb belt tension at high RPMs like that. Pin moves freely is a bald-faced lie, unless they include an extra unwritten step, or that's just a mistranslated what pin moves freely means in English. If you find yourself in this position on the 2G timing tensioner job, you don't have to do the whole thing over. The point is just to get the tensioner to extend out to its service limit. You're too tight. Big deal. Just slightly over torque your tensioner bolt on your 2G, which is not going to hurt anything. Remember, it takes the tension off the belt on the 2G. The pulley's going to rotate with the bolt. Still, turn the engine over twice and line it all back up again, and the 15-minute wait thing, but you don't have to go all the way back to step 13 on a 2G if you just fall short. Small adjustments are going to make up a big difference here. You can exploit this engineering issue to your advantage and sneak up on perfection with that little unwritten step. So if you get the tension right, the pin's going to rotate, but only while you're pushing it around. It's not going to be binding, but I wouldn't call that rotating freely. It's certainly going to have some resistance on it because the pin wants to be a millimeter extended, and if you did it right, then when you pull the pin, you're not going to be able to reinsert it. You're only going to be allowed to use 2 of the 3 holes. The one on the back is going to be off limits forever. What? The only thing that matters on a 4G63 timing tensioner job is step 19, where you measure the clearance after completing that full procedure and the 15-minute wait. You need the adjuster to extend so that it can absorb your belt deflection at all RPMs. You can actually measure it before the 15-minute wait even begins to see if you're even near the ballpark that you need to be playing in. That's why they say to check the tension on the pin in the service manual. But even that instruction is wrong, or at least vague, because the pin moving freely can still be wrong. But my method somewhat disregards the inch-pound torque load, at least where anything other than finding the tensioner pulley angle to start with matters. I modify it by adding a little bit of extra tension, because tightening the bolt's going to rotate and loosen it slightly. And I add step 20, which doesn't exist, to over-torque the tensioner pulley bolt to achieve the correct gap at the tensioner assembly afterwards. All this does is prevent you from having to do this over and over and over again, failing because the instructions are the old instructions from the 1G stuff where the tensioner pulley rotates the opposite direction and doesn't have any of these issues engineered right in. But as I said, the only thing that matters no matter what generation of a 4G that you're timing is that your timing marks all line up and the gap on the tensioner falls within the range of the specification listed in the service manual for your engine. The factory service manual procedure is only going to get you close on the 1G, and it's going to leave you frustrated and wasting your time on the 2G. This is how I deal with it. The whole process itself matters less than that gap at the end, but try to use it and get a feel for it anyway. You've been warned. I managed to get 4.01 millimeters worth of feeler gauges through it. I tried to fit 403 and barely couldn't, so it looks like 4.02 millimeters is what I have. That's about the middle third of spec, and I'm adding a fuel pump drive to my exhaust gear, so that's actually where I want it this time. But I'm not done yet. It's assembled and the timing basics are complete, but I want to fine tune and dial in my camshafts to their correct installed centerline angles so that I can make the most of their profiles and performance. I've already made an extremely detailed video about this called Degree DOHC Camshafts, where we explore how to make the tools, calculate centerlines, lobe separation angles, the whole process and what all this means. When I watch that video today, I can't believe I even made it. It's probably one of my best videos that I've ever made. But just like the Gallant block, I'm just finding my camshaft center lines by measuring the maximum lift at every degree that I can find it on, marking it on the degree wheel, finding the center of that range and calling it a day. No test springs, just getting right to it. Each single tick mark on the cam gears are 2 crankshaft degrees, so however far off I am, I just need to divide that number by 2, and there's the camshaft degree adjustment that I need to use. It says 107 here, and you might get excited to see 107 on the card, but that's the intake cam, and we're working on the exhaust cam, so off by 7 degrees. I need a 3.5 degree adjustment to make that one 113, and I need to advance the gear because the crankshaft rotates clockwise 107 degrees before top dead center actually happens after that. I loosened all the bolts and I advanced it, then take measurements to check my work again, and it looks like we're good. Next, we just do the same thing for the intake cam. Measure all the max lift points on the intake valves, split the difference, and that's the current installed center line. Compare that to spec. Subtract the result from the spec, and then the intake cam's about 7 degrees advanced. So I loosened the intake cam gears, retarded it about 3.5 degrees, trying to hit 107 instead of the 100 degrees that I measured, locked it all back down, and then checked my work again. Oh yeah, baby, we live. We got the dial gauge back on number 1 so that we can check top dead center. We're not doing a voiceover now, I'm going live because I'm trying to put some emphasis on this. Doesn't matter what you did with the degree wheel and all of your careful finagling with all of these parts to get them set, if you don't go back and check your work to make sure nothing got bumped, moved, or whatever. Because all it takes is one little 2 degree accidental something moved on the wheel or the pointer, and now all of your cam degrees are off by that much. So it's the most important thing. After you got it dialed, check your 0 point on top dead center. Head is assembled and torqued, engine is timed, cams are degreed correctly because here's top dead center dialing right back to 0 again now that I'm finished. Lady and gentlemen, we have a whole GSX engine, and I'm sorry this took so long. However, I offer no apologies for how these builds have turned out. If it happened any sooner, it wouldn't have been anything like this. It's done, people. The GSX has an engine, and it's dialed. Sure, I've got an engine. I mean, the core of the machine's basically complete, but I've still got a ton of other really cool parts to put on here. I can't spend as much time on all of them as I'd like to because I've already kept you all for long enough. And there's one other thing that I want to tell you about while I break my promise and make you accidentally watch another polishing segment. And that is, the reason my hair was long was because the last time I picked up my block before the lockdowns, on like the third or fourth time that the 6-bolt assembly went sideways, I swore that I wasn't going to cut it again until I had a complete engine for the GSX. I didn't even wait 12 hours after I was done with that last scene. My wig's already been split. I couldn't take it anymore. Just in case my melon goes by, I don't want you to be like, who's that? I polished this seal from the rough in just about an hour doing all this the machine way, but just to finish this one little detail. It turned out pretty good, but not quite as nice as the other one that I'd completely hand finished. Only I would have an opinion about that, I swear. Next, I cover the top of the seal with RTV, dab all the corners of the caps, and I can finally seal up this valve train with the valve cover and snug all the fasteners. Normally I wouldn't clean up the excess RTV, except on a build like this one I do. It can make a worse mess doing it, but you know, if you wait 20 minutes before cleaning it up, you won't. It comes off cooperatively. I used silicone spray to lube the O-rings just so I don't pinch or cut anything by accident. This pipe's bolted on, so that lube's not going to make it come loose under pressure. Sometimes there's an O-ring seal included with your gasket set, and it came from the factory with an O-ring style seal for the part where it goes against the head, but the factory overhaul manual actually just recommends using RTV here, and that's what I've always done. Never had a leak. Never had a problem. The fancy ARP polished stainless steel hardware was all sourced for this one's exterior during my original build. I have over $1,000 invested in this engine just in fasteners alone. Of course, that's everything inside and out, but it's really nice to see the final bits and pieces finally coming home again. Another thing that you've seen me adding in several other places are these threaded stainless plugs to cover up unused bolt holes. It's better than letting the mud daubers do it for me. The now discontinued factory seal for the 95 and 96 cylinder heads. That's nice. I actually did this very poorly. I have to go back and fix it later. On the intake side, I got a Torque Solutions heat barrier gasket to prevent heat soaking my intake manifold from the flange out. What better part is there to hold this gasket onto this build with than that ever so shiny OG Magnus sheet metal intake manifold that you watched me polish in the last video? There's likely some changes coming to this one, so I'm not torquing it just yet. This 16 ORB port that lives on the front of the engine is often used as a breather port, or you could install a vacuum pump, but I'm not going to do that unless I have a blow-by problem, so for now, I'm removing the hole. Of course, the fuel system needs to be completed, and most of that lives on the car. I don't know what or if I'm going to use as a timing cover, but this Morrison fabrication exhaust manifold is the one that I said that I wish I could spend more time on in this video. But I gave everyone a really good rundown and close-up of this one's unboxing in the What Will the GSX Build Look Like video. Oh man, I almost left out a really important piece of bling, the coil on plug ignition plate. This part might have to change in the future against my will, but if it does, what I put back on here is going to match this theme. If you get to be the one to hover over this engine bay, you're going to see yourself all over the place in it, and I hope I get to share that with you someday. But now, with both of these engines assembled, minus one set of cam gears and of course an hour's worth of timing work just left to do on one of them, I no longer need a clean room anymore, and this is always supposed to have been temporary. We're done with the engine building phase for a while, and I'm really glad that I went through the trouble of building this because I knew I'd be running back and forth making a big mess, fabricating, restoring, and polishing all the parts that are going to be used to assemble all this. So I absolutely had to separate these spaces to avoid that fallout, and it did a great job. But just like the haircut, it's got to go. We're moving on to the next phase of awesomeness, and another bay is far more valuable space to me to have right now. If you followed my story about the World Cup Finals, it's only my Patreons who made it possible for me to create the videos and the engines that I imagined back then. Y'all knocked it out of the park, and I'm excited to enter the next phase. Like and comment if you want to help me get there faster, subscribe if you want more, or maybe head on over to Patreon for some extra content and discussion. I'm happy with this progress right now, so until next time, stay tubed.